Today is the 14th of January, and as you can see, the temperature is 13 degrees with a wind chill factor of 12. I'm not going out in that crap. We're also supposed to get 3 to 6 inches of snow beginning in a little while. I was going to go out, pull the steering column out of the Thunderbird. I just don't want to do it. I've had a couple guys tell me, a couple of our good subscribers say, get that column out of there. Okay, I'll do it. But I'm not going to do it in this kind of just going between the house and the garage. It's just too cold for me. So what I'm going to do is I have another radio video that I made. It's sitting on my computer, all edited and everything, ready to go. I'll just go ahead and upload it. So you lucky folks today get to be the recipients of more of my radio drivel. So let's get on with it. Well, hello again. I was going to start this video out by removing the tuner, as you know from the last video that I put up. However, something came up. My mentor, Brendan, up in Detroit, he said I painted something when I told you about. He said I painted it with a broad brush, meaning that I established a hard and fast rule that necessarily isn't a hard and fast rule. And he was talking about the metal sheaths on these tubes. I said that pin 1 had to be grounded on all of them. Well, that was told to me by some experts on the Antique Radio Forum, and I have never seen one where pin 1 was not grounded. But that doesn't mean it's a hard and fast rule. That's what Brendan is trying to say. And I've got 16 years of experience at this stuff, and he's got a mere 60 years. What does he know, right? Anyway, I'm going to go ahead and pursue this a little bit because I think it's important. There are radio companies that made things different than the rest, and I'm going to give you an example. You have to be aware of this. Not all radio companies had the same standards and the same type of setups in their radios. They weren't universal. They were close, don't get me wrong. They all pretty much are the same. Different types of adjustments, different types of locations for parts. Caps were the same, resistors were the same, sockets were the same, tubes were pretty much the same. And you had your volume controls, you had tone controls and things of that nature, and band switches. They're all pretty much the same. But some things were different. I'm not sure why they did that. It didn't make it. I would assume that the same engineers that designed all this stuff graduated from pretty much the same schools. But I guess they were striking out, trying to come up with something different. Atwater Kent in particular. I think Atwater Kent radios are overrated. I just, everybody said they got fantastic looking cabinets, and he was one of the first to be doing all this stuff with his company, starting back in the 20s. And he was a smart guy. He made millions of dollars and provided a livelihood for many people. And but the way he did things, he was I guess you call him a rebel. He had his own way of doing things. I'm going to show you an example here in a second. Let's take a look at the resistor in this Airline. Now, this is a dog bone resistor, but the color codes are the same. So what I told you, there was BED, body, end, and then of course the dot on the resistor. Let me get a little focus here. You'll see that the body is brown, so that's 1. Green, let me back up a little bit here. Green is 5, so that's 1, 5. And then the orange dot on the side, body, end, dot. There we go, okay. That's 1,000. That's a 15,000 ohm resistor, 15K. Now that's standard colors for the, for electronics. They came up with a standard coloring code. However, Atwater Kent, that was his name. His middle name was Atwater. Not him. He went with a color code of, his color code was 15, was gray and yellow. You see? Gray and yellow. So essentially what am I trying to say here? What I'm trying to say is that you can't paint resistors with a broad brush, okay? Because there are exceptions. There may be others. I don't know. And I always thought that when I started working on Atwater Kent radios, I never thought they were that good. I still don't. He had his own way of doing things. It was kind of stupid why he didn't adopt you know, the more modern materials and codes and things like that. He was just a stubborn old guy. And in 1936, he decided to just give it all up. Everybody went out of business for a couple of reasons. One was it was the middle of the Depression. Sales weren't that good. Second, his workers who had jobs, who were making money, they decided to go on strike and all this other crap and threaten him and all that. He said, you know, forget this. I don't need this anymore. I'm an old guy. I'm a millionaire. He just closed down the whole factory. Everybody was out of a job. You know, can you imagine? You know, they wanted more money during a Depression era, and now they were out of jobs completely. But, you know, that's the American way of doing things, I guess. So anyway, let's get back to what I was talking about. Brendan, whenever Brendan says something in electronics, I listen. I can't remember him ever being wrong, ever. One time he might have said he was better looking than me. Now that is definitely wrong. Anyway, let's go ahead and connect with pin 1. Now pin 1, you count from that little bump. See that bump on the side of that black thing right there? That's the key. Let me get over here where I can see better. Bring this up here so I can point with my pencil. I gotta have my pencil, you know. Okay. That's the key right there. And you go clockwise around the key. When you look at the bottom of a tube. Clockwise from the key. Now that key is splitting these two pins, as you can see. So the first one to the right is number 1. And this one's number 8. 1 and 8. So, by my theory, and having never seen it different on any other black metal tube, this should be pin 1 connected to this metal case. Let's find out. Now, I'm not saying that Brendan's going to be wrong, even if it is connected. let's just make sure that's the case with this particular tube. So, let me see, pin 1 would be this one right here. Now, we'll take our little multimeter probe and hook it to the other one. There we go. See if I can find a bare spot on this tube somewhere. Gotta be one somewhere, there always is. No, come on, where are you at? I know there's gotta be a bare spot here somewhere. I don't know, what's this right here? That looks like a little shiny bit right there. Let's see if I can press the needle through there. Okay, there it is. Okay. Now you can see. There's 26 ohms, 26, I don't know what it is, jumping around a little bit. But anyway, that proves that pin 1 is connected to that shield, okay? Now, he told me some other things that I'll go in at a later date, but not right now. So I don't know. So what do you do? What do you do? You know, he's right. I'm probably painting this whole mess with a broad brush. And but at the same time, I don't want anybody getting electrocuted because they don't know that pin 1 should be connected. Let's check the chassis and see what it says. If you're never sure, you can check the tube to see if it's connected to pin 1. You can then go to the socket and make sure that pin 1 is connected to ground. Let's find out. Okay, there's the key again in the socket. Let me get this light over here a little closer. There's the key in the socket right there, that little hole where the key fits. And to the right, going clockwise, that would make this pin number 1. The first pin to the right of the slot, pin number 1. And it looks like we've got pin number 2, pin number 1, and pin number 8 all connected together. Now, does that go to ground or what? I don't know. We're going to have to check that out with the multimeter too. I have connected my red lead from my multimeter to any one of the 3 because they're all connected together. This is pin, I guess that's pin 8 that I have it connected on, but it doesn't matter, any one of the 3. Because they're all connected together, same old, same old. Now here's our meter. I'm going to go ahead and just touch the black probe to the ground here, like so, and see if we get a reading or not. We should get a ground, we should get continuity. There we go. There it is. Okay, we have continuity. Alright, that means that, yes, pin 1 is connected to ground on the socket also. Now comes the next step. This is something you should be doing until you're comfortable just by looking. After a while, you'll be able to say, oh, I know what this is, I know what that is. You know, just be sure when you say it that it's right. So I've been wrong many times and have to spend, you know, 20 minutes trying to figure out what I did wrong and then fix it. All right, we now know those 3 pins, 1, 8, 1, 2, and 8. Now, why is 1, 2, and 8 grounded and they go back up here through this wire up into the transformer? Well, that's kind of strange. Let us find out why that's happening. Years ago, when I first joined the Antique Radio Forum, there was a fella on there named Kurt Reed. Kurt Reed, in my opinion, was a genius, and he had a way of relating to newbies. He was a tough old bird, you know, Navy veteran, that kind of guy. He lived in a house trailer all by himself. He had been a ham radio since he was, I guess he was 6 months old, but he knew all about everything. He really did. He didn't have a whole lot of patience in some respects, and I'll tell you what one of them was here in a minute. But old Kurt, you know, I latched on to him because after watching the Antique Radio Forum for a few days, I realized that he was up there every day, and he was a connoisseur of the cold 501, I guess is what it was, cold beer. He drank a lot of beer. Anyway, his kitchen table leg was busted off, so rather than get it fixed, he just propped it up with an empty Army ammo can. And you know, his daily thing was to go out and feed the squirrels. So, but he talked electronics all the time. He lived it, okay. And he was a ham. He talked about the old days as a ham radio operator, and he's quite a fellow. And one of the things he told me was, John, what you need to do, and he was one of the first guys I latched onto, like I said. This was long before I even met Brendan, years before I met Brendan. Anyway, he said, what you need to do is go out and get yourself an RCA tube manual, and you need to get the RC14. That's the one you need right there, RC14. He said that one. He said later on you can get some more, but he said this is a good one to start out with for these antique radios. They'll have everything in there that you'll need to know as far as tube construction, voltages, currents, pinouts, all kinds of stuff. So I did. I went on eBay and I bought one of these. And of course, this was back in, I guess it was back in 2005 maybe. I can't remember, before I started my first radio. And because, you know, when you first start out, you go to Antique Radio Forum, you don't jump in there and say, oh, I got a radio, I got to rebuild. Is anybody going to help me? Forget all of it. No. You do a lot of research, you prepare yourself, because they're going to be asking you questions. What about this? What have you done about this? Have you done anything about that? And you've got to be able to give them the answers. They don't want to deal with some blithering idiot who just wants to buy a radio and jump in there and have them tell them how to do it. They lose patience with that, and I don't blame them. If you're not going to do your research, they have a search function on Antique Radio Forum, and you'll get guys in there that'll ask questions that if they had just done the search function, they could have, the question was answered 25, 30, 40 times already over the years, okay? You got to put a little bit of effort into it before you bug them. They have other things to do with their life, too, besides entertain, you know, lazy morons. Anyway, the bottom line here is I bought the tube manual, and it's helped me so many times. So let's look up the 6F6. On page 106 is your 6F6 tube, both the metal and the glass. That's what the G stands for. Now, it's going to be a little bit difficult for me to hold this book open and use my pencil at the same time and the camera. Anyway, what we have here is pin number 1, pin number 2, and pin number 8, all connected to ground, okay? That's what we have. Simple stuff. Anybody can figure this out. Now, why did they do that? Why did they tie all 3 of these together? Well, one of the grounds goes to the heater. See, this is your heater right here. So one side has the power, the other side has the ground. So that answers that question right there. And then, of course, number 1 is ground because it's connected to the tube shield, that black metal tube shield. What about number 8? Number 8 goes up here and it connects to the cathode. The cathode goes up and it connects to the suppressor grid. So any electrons that go driving across the tube that may bounce off the plate and start jumping around inside the tube, it'll be picked up by the suppressor grid, sent back around, and that, of course, is to ground because the cathode is grounded on this tube, in this circuit. Okay, So all three of these are grounded. And that's the deal on that, okay? Alright, I hope you understood that. The Airline 62198 is really a poor schematic. Everything jumbled together on this 6F6. But, you know, since I have a tube manual, it made things a little easier. This is your suppressor grid. This is your plate right here. This is your suppressor grid tied back to what? Well, the cathode. So that's got to be the cathode, which is connected to ground. It does not show pin 1. And that's just sort of a given, I guess. It's a blank pin in the tube manual, and it's been connected to ground. So, you know, you could put a little circle there, put a 1 in there, you know, whatever you want to do with these schematics. They're your schematics. You want to paint them purple polka dots to help you read them or help you follow them. There's a difference between following a schematic and reading a schematic. So what's the difference between following a schematic and reading a schematic? Following is easy. It's just like a road map. Everything is either north, south, east, or west. North, south, east, or west. I mean, it's as simple as that. If you can follow a map on a highway map, you can follow a schematic. You just got to, you know, follow a wire, keep following it till you run to the resistor you're looking for. And of course, you look down here in the parts list to find out what the value of the resistor is, and it'll tell you the color code, and you're good to go. Yeah, I can follow anything on the schematic and find out where it goes. Reading it's another story. For instance, what's the purpose of this resistor here? What's the purpose of this resistor? Why are there two resistors, you know, back to back here? Yeah, I'm not really certain. Yeah, well, it's obviously to cut down on voltage, but why? You know, see, that's all called reading. See, what does this do? What is the purpose of this one? What is this capacitor here there for? You know, that's called reading a schematic. That's what engineers design. Now, a guy like Brendan and Kurt Reed and a bunch of millions of others who have been at this more than a week and a half, they can read. They know what every part in here does. They know exactly why it's there. Not me. I have a lot of problem with that reading, but as long as I can follow and get the parts in the right place, the right part in the right place, I can make it work. I can make it work again, no matter how bad it is. And once we get to the Atwater Kent 856 chassis, you'll find that out, because right now it's all tore to pieces. I don't know who did that. Yeah, I do. It was me. Oh well, let's move on. Okay, we are back to removing this tuner, finally. All I'm going to do is remove the tuner, and that'll be the end of this video, because I spent so much time on that other stuff, but I thought that was important. Not everything is the same manufacturer to manufacturer, is what I guess I've been trying to point out, which is exactly what Brendan pointed out to me. Although, like I said, I have never seen one of these that didn't have pin 1 grounded. He also pointed out something else to me that I'll show you at a later date with a different radio, I think. But if you're a new guy, you don't need to get bogged down in that crap. This is just basic stuff. If you're not sure, I just showed you a way to figure it out. You can figure it out. You'll learn schematic following. You'll learn different tubes and how they're configured and what they're for and stuff like that. You know, don't worry about it in the beginning. Just find you a small basic radio. And my advice is do not find... My recommendation is that you do not start out with an AA5 radio for your first one. They're pretty dangerous. And one more thing, before we remove this, I got a question. One guy says, hey, you know, you talked about the isolation transformer. Well, won't this work as an isolation transformer? Well, of course not. That's why it's called a power transformer. Isolation transformer, power transformer. They're not the same. This transformer is a 1-to-1, 120 in, 120 out. Yeah, some of them have 40 in, 40 out. They're 1-to-1, okay? This one here has 120 in or 115, whatever is designed for the radio, and you might have 400 volts out. And this one is connected to ground. This one is not. So if you develop a shock, see, this isolates, connecting this to that isolates you from ground. That's the design of it, okay? But, you know, for someone to even ask, after I went over this, for someone to even ask, well, won't this do it? You know, there's a guy who doesn't believe what I'm trying to tell him. which is fine, you know. But he's the guy that's also going to get shocked real bad someday. Oop, I keep hitting my camera. I don't know why I do that. Someday he'll wind up getting shocked really bad. Hopefully it won't be too much damage to him. Again, isolation transformer, do not work on these things without them. And I will put a link down below the video. I want everybody to watch that if you're new. It's to a video that was put out by Paul Carlson, Mr. Carlson's lab, several years ago. And he tells the difference between, he explains it in really good detail and demonstrates it. The difference between a power transformer and an isolation transformer. The guy that asked the question about this, watch that video and maybe you'll understand what I've been trying to tell you. I had one guy one time ask me, well, what about a Variac? That does the same thing. No, it does not. A Variac is a Variac. It's not a one-to-one transformer. It's a variable. I mean, look, guys, you know, do what you want. Isolation transformer is my recommendation, okay? It was told to me right off the bat. That's one of the things that I got, and I was very happy about it. I think I got it later. In the beginning, I used just the Variac, and then I picked up an isolation transformer when I got the money. All right, let's get it on with this tuner. I'm going to get these nuts off of here. And when you're done, I recommend you put the nuts back on the studs that they came off of so you don't lose them. Here's something you'll for sure run into someday, maybe right off the bat. What I have here is a variable capacitor that's, even after I took the nuts and the washers off, it's so tight to the board. I mean, as far as space goes, there's almost no space. It won't let me see what's underneath it. So I have to go below. And it looks to me like there's 4 wires. I don't know. So I dug out 4 different color pins that I have. And, you know, it's a good idea to keep some of these things on hand, different colors. They come in handy for radio work a whole lot. You know, there's a, I think there's even a pink one you can get. Who knows? Anyway, what I'm going to do is I'm just going to color code those wires. I'm just going to take the pen and I'm just going to draw the color right on it. And then I'm going to write down, which I've already done already, I'm going to write down on the schematic. I'm going to say these are the variable cap colors. The black one that I mark in black is going to be the front wire to the variable cap. So let's do that and then you'll know what I'm going to do with the rest. Alright, we'll tip this up. This is the front connection right here. I'm going to make it black. If it needs a little more, I'll add it on there. But that's the black one. And I'm going to do, I'll pick red and blue or orange for the remaining ones, but that's all I'm going to do. So when it comes time to put them back on, I know which one goes where. Because some of these wires are the same color. Anyway, here's our colors for our cap, besides the black. When I put the blue on the wire, it kind of turned a bluish, so I made that the middle. That's a bluish mark. And then the orange and the braided wire both go to ground on the chassis right here. You go to that big old grounding tab right there. Big old giant tab. Let me see if I can get you a better shot of that so you know what that is. It's a grounding tab, fastens right to the chassis itself. And I wrote braid, ground right there. And then the red, it goes also to it, okay? Well, you know, as usual, I sort of expected it, and it did happen. I've color-coded the wires, but what they did at the factory is they wrapped these wires around and around. And this one here I managed to get off because it's a nice thick one, and it wasn't wrapped almost completely around. It was just like 3/4. That's the ground. But the rest of them, this stuff is pretty flimsy, as you can see, pretty flimsy. I don't want to break any of these tabs off and, you know, trying to get that thing off. So what we're going to do, we have the color codes on the wire insulation, and I'm just going to put extender wires on and, you know, and splice them on a little, maybe, you know, maybe about that long when the time comes. And then we'll use those and we'll solder them up the right way. So meanwhile, to get that thing loose, I'm just going to go ahead and snip it. Okay, it's color coded. We know where it goes. There's one. I'll do this now to the braided wire. I don't know if I'm going to have to do it to the braided wire or not. That's a pretty thick wire right there. I don't know if you can make that out. Let me get over here where you can see it. See how the braided wire is? It's kind of a pretty thick wire. A lot of solder in it. God, I wish they hadn't have done that. Anyway, I'll go ahead and snip the rest. We'll get this thing out of here the best I can. Patience is the word of the day here with your tuner. Don't screw it up. As expected, once the tuner came up out of the chassis, I still had another one here. It goes down to these trimmers down here. So what they've done is they took a couple of pieces of, let me zero in on it. I don't think I've ever seen this before. They took a couple pieces of metal and squeezed them together on the insulation and then soldered the wire to right there. So what I've got to do is separate this with a screwdriver to where the insulation will come loose. It'll take 2 hands to do it, and then I can go ahead and hit this with a soldering iron, and that wire should pop right out. And then we will be free from the chassis. Alright, it's time to wrap this video up. This tuner, by the way, was made by the Reliance Die Stamping Company in Chicago. How about them apples, huh? And just a 2-gang tuner. And I've never seen this many connections on a 2-gang tuner. This was kind of surprising. We had 1, then the ground is 2, then 3, 4, and then another one over here on this gang here, which is 5, that runs down to the trimmer caps underneath. These things here are what those rubber bushings will be going around, those collars. One of them unscrews. Yeah, to see this one unscrews with no problem. The others are stuck. won't come loose, and this one won't come loose either. But I think after it's run a few times through the ultrasonic cleaner, that'll loosen them up pretty good. Then I'll remove all the excess solder that I don't want. I'll probably replace this mess with a nice ground black wire, 600 volt they can handle, and then we'll clean it and it'll look. And then we got bearings. We'll have to oil the bearings. See those bearings down there, the ball bearings? We're gonna have to order those, oil those, and then when we're done, now from here on out, we're going to try to keep the blades in as much as possible. Don't let them come out. Once they start bending, man, you'll be there for 3 hours trying to straighten them out. Trust me, I've been through it. Okay. Until next time, this is John.